My name's Anthony Medina, and I attend Bowie High School.
My name is Anoman King, and I attend Vandergrift High School.
My name's Ibrahim Musa, and I attend Lhasa High School.
And our project is Rock Ridge. The location for our project is within Alice Wainwright Park, Miami-Dade County, Florida. This location is ideal for our water management projects as it is within close proximity to the seawater. The rising sea levels and the number of occurrences of flooding along with the contaminated Biscayne aquifer can introduce the possibility of providing a clean source of drinking water to the local area of about 3 million people. The area is consisted of about 80% trees, a small recreational area, and it's very close to the shoreline with minimal wildlife, and it is right next to the main highway, which is on the east side of the park, and northwest and across the street of northwest and across the street with residential area. Sorry. Next slide.
To solve the contamination, we first thought of purifying the aquifer, but we chose not to because we couldn't reach our goal of providing water for the immediate community, so we chose to purify the seawater instead. When we started designing, we knew we needed stilts because of the proximity to the shore, so we wanted to play with elevation, seeing how we can engage the public and maintain the park's atmosphere. Next slide. The Keppel Marina plant inspired the green roof of our building, and we used the Fort Pierce plant as a reference for the desalination process.
All right. We were also inspired by Big's waste to energy plant with a unique sustainable design and a sloped green roof. And we were also inspired by the Perez Art Museum, which is also located nearby Miami, Florida, the same as our project, and showed us how the building uses stilts and its Miami art style.
Our final design is a desalination plant next to the public area with a holding tank adjacent, and there's a walkway that wraps around the holding tank and goes to the roof of the desalination plant, which has a garden and a skylight where people can walk across the roof and look out to the sea and look out to the forest and stay immersed in the park kind of atmosphere. And then on the south side of the building is a staircase that leads down to the first floor of the building, which is where the desalination process happens, and then down to the public area as seen on the right, which is a place where people can sit, talk, walk around, and in the back is a wooden structure that conceals the pipes from the desalination plant to the holding tank. Next. We wanted to keep the ideas of sustainability throughout our design, so we used reclaimed wood for the walls, the ceiling, and the stilts, which are reinforced with recycled steel. And for the furniture, we used cork and recycled plastic. Next.
All right, shown here is a physical model with 4 large glass panel windows. And yes, those are people inside. And our green roof with the trail leading the residents up the staircase, leading residents up the stairs across the green roof, and finally down to the water tank, in which there will also be a smaller green roof on their way down.
All right, so I'm going to be talking a little bit about how the desalination process works. So on the left, you can see a site map of our entire plant. The red rectangle represents the actual plant itself. The blue circle is the tank, and the black lines represent pipes. So the first step is bringing in seawater into the plant, and from here we add a series of chemicals, specifically coagulants and flocculants, to help aggregate particles in it to remove them from the water. The water is then passed through a preliminary filter that removes large objects like trash or plant life, and from here the water is passed to the reverse osmosis chamber, where it is sent through a series of semi-permeable membranes. These membranes remove really small particles that could be harmful, and that's sent back to the seawater. But the remaining water is sent to the next stage where chemicals are added. So biocides remove harmful life matter, and pH regulators to make sure that the water is not too acidic or too basic. And at this point, the water is safe to drink and it's sent to our tank. So here's our cost estimate. The most important thing on the screen is the production. So we estimated that we were going to be producing between 16 and 20 million gallons per day. And this estimate was derived from the community that we wanted to cater to. So the first thing that our team did was we researched a bunch of other desal plants in the area. So there were a couple in Florida at Tampa Bay and Cape Coral, but we also looked at plants in California and the Middle East, and this helped give us an idea of how much this thing was going to cost. The next thing we did was split up our costs into different components. So there were three main things: the hard costs, our soft costs, and the land acquisition. So the hard cost refers to our structure and reverse osmosis technology. The structure was by far the most expensive, totaling over $100 million. But the reverse osmosis technology combined with water treatment was close to 100 million as well. Land acquisition was around 15 million, and we got this number from the Miami-Dade property search. And then soft construction costs, we looked at local contractors to get an estimate of how much a project of this scale would cost. And our final expense, including contingency, was a little over $300 million. Next.
All right, in the construction schedule, it is noticeable that there are 6 distinct phases. The first phase includes the schematic design, community development, design development, and construction documentation, which in all takes about 5 months. The second phase includes the permitting that is necessary, and the estimating, the material and reverse osmosis delivery, which in all takes about 9 months. But the reverse osmosis machines require special delivery time, which will fit our needs towards the end of the project, and that alone will take almost a year for that delivery and that implementation for the machines. And the excavation preparation for site layout and concrete foundation is the third phase, and it'll take about 6 months. The fourth phase includes framing, roofing, and exterior finishes, which will take almost a year. And the fifth phase includes the electrical, plumbing, and HVAC, as well as insulation, sheetrock, and wall coverings, and flooring, which will take a little over a year and 6 months. And finally, the last phase will include landscaping, moving out, and the final inspection, which will take about 8 months. Overall, the project will take 4 years to complete, starting in August 2024. Starting in August 2020 to June 2024. And here's a short clip of our physical model. All right.
So a little bit of our reflections on the project. Personally, the aspect that I most enjoyed was finding a solution to a problem that actually exists. So there were a lot of different paths that we could take. We could have gone through electrodialysis, we could have used mechanical energy or evaporation, but finding the route to eventually get to reverse osmosis was really rewarding. The biggest challenge that I faced was the lack of data that is out there. So not a lot of people are publishing their construction budgets or their timelines for desal plants. So we had to conduct a lot of deep research to find estimates for our project.
My favorite part for the project as a whole was working with people from different fields of backgrounds. That includes my mentors and also my team members as well, who had various experiences. And the challenges was actually also the teamwork in a way, because I believe we should have had more time to get to know each other and learn our strengths and weaknesses, and use that as an advantage to develop our project too, and see which part fits best with whom.
I most enjoyed the freedom in getting creative with how we designed the building and how we solved the problem, and also learning InDesign as a presentation program. And what was most challenging for me was communicating my ideas effectively in the beginning, but once we started working together and getting comfortable with each other, it was a lot easier. These are our references for our sites that we used for most of the research for the site, the precedents, and the desalination process.
Thank you for listening.
Yep.